we are going to solve question number 3 now. Find the acceleration of the particle when t equals to 1. It's the same. If velocity expression is given here, v equals to 4 e to the power twice t plus twice t. To get from velocity to acceleration, we have to differentiate first. dt of velocity expression, we are going to write 4 e to the power 2t plus 2t. So differentiation of this exponential differentiation from coefficient of t, it comes from, so 4 to the 8 e to the power 2t plus, if we differentiate 2t, so only t comes, 2 comes from there. So this is our value, and add expression for acceleration. So at the time t equals to 1, so let me write when t equals to 1, our acceleration equals to, you can write here 8 e to the power 2 into 1 plus 2. So our final expression, you can write 8 square plus 2, and acceleration of the particle, so we can write this is our answer because its unit is meter per second square. Done. So next question written here, find an expression for the displacement from the velocity. If we wanted to get displacement, we needed to integrate. So let me integrate now for question number B. Displacement we can express as s integration of v dt. In this stage we have to do, so integration the velocity expression, this is the velocity same expression, 4 e to the power 2t plus 2t dt. This expression we are going to integrate. So which for coefficient of x, now we needed to divide because it's the integration, 4 by 2 e to the power 2t, then in that stage 2t square divided by 2, because we are going to add the power 1 with power, so then plus c we have to write integration constant. Then the final expression you can write s equals to 2 e to the power 2t plus t square plus c. So we have to find out now the value of c. It is the same like question number 2. It was what written, t seconds after passing through O. It means that at the stage of t equals to 0, when t equals to 0, t equals to 0, so we can write its displacement was 0 as well, because it passes through O, and that is a starting point. So we can put this value here to get our value of c. So 0 equals to, let me put this value 2 e to the power 0 as well, because t equals to 0, then 0 square plus c. So 0 equals to 2 e to the power 0, we know e to the anything power 0 equals to 1, so it gives us 2 plus 0 plus c. So finally it would c equals to minus 2. So let me write our expression for the displacement, written here. So we can write here s equals to displacement expression. Here we are going to put the value, the c, our value c we got minus 2, which you can write 2 e to the power 2t plus t square minus 2, and this is our expression for the displacement. Now the next question is, find the total distance traveled by the particle in the first 2 seconds of its motion. So same thing we can do here like the way we did the question number 2, just it is written here second. So we s2, this is the total displacement by 2 seconds minus s0, then we will get the answer from here. So we can write the displacement by in terms of t, st equals to this. So we are going to put value 2 here, 2 e to the power 2 into 2, then plus 2 square minus 2 minus, if we put there 0, then it becomes 2 e to the power 0 plus 0 minus 2, then finally 2 e to the power 4 plus 4 minus 2 is 2 minus 2 and again plus 2. 2 we can cut out, so 2 to the power 4 plus 2. This is our exact value of the distance traveled in the first 2 seconds, but the question is written here, give your answer correct to nearest centimeter. You have to use the calculator. Let me put the value in our calculator. 2 shift here exponential function e to the power 4, then right there plus 2 and we would get from here 111.19 111.192 it was. So if we write in 196, sorry, 196, so if we write it in near centimeter, definitely it would be 111 meter. So this is our answer of this question number 3C.